put molecular platform. Okay. So the first thing was, how can we use a microarray where we can take multiple patients, as much as 10 patients or 15 patients, without getting any crosstalk and any kind of cross information, and be able to put all those DNA all on the same chip and find its assigned spot. Let me take an example of an HPV. In the HPV, we know we have to look at 14 high risk. So every patient will have at least 14 spots which are assigned to that patient for each of the type of the risk we are looking at. The next step is we want to do that in triplicate to ensure the performance of that microarray and that process has taken place. So every spot, if you took and multiply that, will be assigned about 42 different spots with all the controls and things which we need. We take then each of those patient sample and we lyse the cell like it's done normally, and then we want to develop a target probe to look at whether type 16 or 18 are present, or whatever types are present. But during the development of that probe, we also assign a unique sequence to that set of probes, which are then allocated to that patient. And by making a complement probe onto the microarray, we are able to differentiate all 6 patient or 10 patient on using the same microarray. Now, what has that done to us? We are now able to increase the throughput by just processing one microarray. We are increasing the throughput by 500% and reducing the cost equally well on that, maybe 1/5 of it. So this is a process which we follow, and it is no human being ever touches any of these processes. It's all done automatically. Okay. Now, just following with this HPV process, and the reason I've selected HPV, there's no really reason for that, other than the fact that this is really a high volume test. It can be done for any other test on here. But in an HPV test, the sample comes in either in a thin prep or a SurePath media or any other media to do the cell preservation. It's transferred into a 96-well plate, and then a centrifuge to get the pellets or the cells pelletized. The supernatant is removed, and then a series of steps are taken place in order to lyse the cell, amplify it, and be ready to do the test. Okay, so this is the whole process which takes place in any instrument which you see, or even the ones which you don't see at this booth. Okay. Now, in order to achieve the test, first of all, I want to assure you that automation doesn't happen overnight. It always takes steps, and we build one on top of the other in order to achieve the ultimate goal which we want to. So initially, as the steps you see right now, we divided that into 3 different steps. The first step was the transfer of samples coming in, and then centrifuge and getting ready for processing. At the present time, we use the assist to follow the sample from the centrifuge time all the way till the incubation takes place. Okay. We then decided that the current system which we have, which only scans 1 microarray at a time, was not capable of handling, washing 100 steps or 100 microarrays at a time. So we developed a scanning method which would scan 100 microarrays. And now remember one thing, each microarray has 6 patient samples. So if you can do 100 microarrays, or you can scan, then you can have 600 patient samples ready to be reported on that. Okay. Now, each of these steps, we then converted that into a box. So even though you will see that we have quite a few of our boxes which look identical, because we don't want to go back and reinvent the wheel by how the case should look like, but the inside is all different. So what we have developed, and which is right now in the beta trial, a series of instruments which will produce 1,000 test results a patient in one single shift. Okay. For HPV, giving you complete genotyping information of 14 high risk. It's not restricted to that. Also in the area of other infectious disease like chlamydia, gonorrhea, trichmosis, all three of them can be done on a patient sample along with the test which we are doing right now. So the system has the ability to mix and match different samples and different systems in order to give that throughput. But the key element is, can we meet the lab's requirement with quality assurance in giving this high-end throughput without any human intervention? So the first model actually does all the extraction, sample handling, and target amplification. The second module actually processes all the signal amplification and transfer the microarray into flats, which is then scanned, result in an analysis, and then transferred to the appropriate pathologist or the patient's file, all through internet. No human intervention and no printing of results. Okay. All of these is combined into an artistic view, and this we plan to come out the semi-automated or the 3-module system is now in beta trials right now. We combined the whole thing into one unit, which will be producing between 12 to 1,500 systems per day, and that we are going to be introducing in the end of 2011. So, what in AutoGenomics, what are things to come is, first, we have 41 or 42 different applications for sale today. As we see by the end of this year, I see this menu growing to about close to 50 to 52. I think we will continue to grow our menu, focusing on the different requirements of the lab. Both increasing the depth in cancer, in infectious disease, many new tests in genetic disorders such as familial Mediterranean fever and thalassemia. Also, we are increasing the density of the chips. So we were marketing microarrays which had 240 spots. Now we are in beta trials for a microarray which is going to be producing as much as 330 spots, and then we are going to raise that up to 1,024. We are developing a high throughput platform which can address the needs all the way from sample to result as high as 1,000 tests per day. So with that in mind, I'm going to hand this over to a customer and a user and a developer of test and see how he can use some of the platforms which I've described. This is Jack.
I'm a Canada research chair in medical genomics.